Hi Diksha Didi, good evening.
Hello, good evening.
So today we are going to continue with our default parameters in default arguments of parameters in C++, right? And we were learning some rules of default parameters, that when giving default parameters, what we have to keep in mind, right? So we were on the second point, so let's just get started.
Okay.
Right. So in the first point over here, we just saw how to use default parameters, and over here we are learning that we have to stay careful when using default parameters. So if function overloading is done containing the default arguments, then we need to make sure it is not ambiguous to the compiler, otherwise it will throw an error, right? So we saw in function overloading that we have to check for the ambiguity errors, and one ambiguity error can also come when using default arguments. So over here we are using default arguments, and when using default arguments with function overloading, it may lead to an ambiguity error, right? So the following is the modified version of the above program. So here we are getting a ambiguity error. So how? So we have this sum function that is returning an integer type value. It's taking an integer x, it's taking an integer y, it's taking an integer z, but that's also a default argument, so it's an optional parameter, right? So if you enter it, then also it's fine. If you don't enter it, then also it's fine. And then we have w, that also is a default parameter. So if you give the value to w, then also it's fine. If you don't give the value to w, then that is also fine, right? Similarly, we have over here the first two arguments over here in this function are integers, and the next two are default arguments that are float, right? And this is also returning an integer value, that is basically x plus y plus z plus w, right? And over here when we are calling sum 10 plus 15, this, what will this do? This will give us an error. Now why? Because when we add 10, let's look at this. It should add 10 over here as it's an integer. When giving 15, it should set the value of y to 15 over here, right? So this function should logically execute. But now let's move on to this function. This function can also be logically executed. When adding 10, this x will get 10. When adding 15, this y will get 15, right? So how does the compiler know that the default arguments that we want is what we want? The default arguments, we want that it should be executing this function or this function. How does the compiler know if we were intended to give a float value over here as default parameter, where the default parameter is, or an integer value, right? The compiler just sees that we have added x, we have added y, right? And that over here can be put in both the cases, over here also, right? X and y can be put over here also, and x and y can be put over here also, right? So we can basically when executing both the methods will not be wrong, right? So both the methods can be executed, but now on a function call, only a single method can be executed, so it cannot decide which one should execute, this one or this one, right? So sum 10 comma 15 will give us an error, as the compiler won't be able to decide that this sum method should be executed or this sum method should be executed, right? So after running this, we are getting this error, that call of overload sum int is ambiguous. So this overloading is ambiguous, right? So over here, let's just copy this code in this editor so that we can work with this code, right? So now over here, if we didn't give this, then it will most probably work fine. Yeah, it is working fine. Why? Because 10 and 15, we are giving 10, 15 and 25. Now 10 can be put here, 10 can also be put here, 15 can be put here, but 15 can also be put here. But 25 is an integer, and over here we are accepting a float, over here we are accepting an integer. So 25 will be passed to the sum method which is accepting an integer, that is this one, right? So now 10 is put over here, 10 is given to x, 15 is given to y, and 25 is given to z, right? And it works perfectly fine. It does x plus y plus z plus w. W is a default argument, so its value is taken to be as 0, right? So when we say 10 plus 15 plus 25, that will give us 50. And when we execute this 10 comma 15 comma 25 comma 30, then what will happen? 10 can be put here, it can also be put here. 15 can be put here, it can also be put here. But next we have an integer, right? So an integer, where will be over here we are accepting an integer, over here we are accepting a float. So as we are passing an integer, it will go over here, and over here we are also passing an integer, so it's going in w. So we have x to be x as 10 over here, y as 15, z as 25, and w as 30. So when we add all of these, we'll get 80, right? So is this example clear? That when removing the above statement where we were only passing two integers, it was leading to an error, but after removing it, both of these functions calls are valid, so it's not giving us an error and giving us the perfect result. So
That's clear.
alright, great. So over here we have to be careful for ambiguity errors, and mostly when overloading we should not use default arguments. Alright, so next we have this third point to remember, that a constructor can contain default parameters as well. So your constructor method that you create in a class, that can also contain default parameters as well. A default constructor, so your constructor can either have no parameters or parameters with default arguments. So your constructor can either have no parameters, or it can have parameters with default arguments, and it can also have normal parameters, right? So we are going to look at all of these, all of those. So now over here we have a class A, right? Over here first we are including IOStream, then we are using namespace standard, then we have a class A. Now we have learned about classes in the basic course also, right? I'll just brief up on classes once, so that we have a quick recap. So classes are basically used to create your custom objects. Classes may contain private, protected, public members, right? And basically any object that you create of the class, for example, then all the public members of that class will be accessible to that object, right? So basically your class is like a cookie cutter. So from cookie cutter you cut cookies, right? So similarly from class you can create object which will have the properties of that class. So if you have created, like over here we have created a method set var, get var, right? So any object created of the class will be able to use set var, get var, etc., right? And this over here is a private variable var, so any object of this class A won't have access to a private variable, right? And same with protected members, any object of this class won't have access to protected members, right? So basically this was a brief on classes that we have already seen in the basic course. Also we are going to see them in a lot of detail in the course further, right? So over here in this class, what we are doing, we are creating a private member. First of all, we didn't need to give this we didn't need to give this private key access modifier over here. Why? Because by default anything that you give without any access modifier, that will basically by default be private, right? So now var over here is given outside without any access modifier, so it's by default private. Now in public, what we're doing, we are creating a constructor method by giving the name of the class, right? So we create a constructor method by giving the name of the class, right? And in this we are taking an x parameter, right, whose default value is 0, meaning if we don't pass the value of x when creating the object, then the value of x then the value of x will be taken as the default value, that is 0, right? And if we pass it a value, then the value of x will be the passed value. And over here, this is the initializer list, syntax. So this syntax that is pretty different for us, this is called the initializer list syntax, where we are giving a colon over here and directly setting the value of var, right, by passing it x. So this is basically over here, let's not just go too deep in this. It's basically what it's doing, it's setting the value of var over here to the to whatever x is passed. So if we pass 1 over here, right, then the value of var will be set to 1, right? And as this constructor method is inside the class, right, so this any private the class member, so in the class itself, so your access to the private member, you can only access the private member inside the class itself. Outside the class you can't access it like on an object, right? So over here basically this constructor method is setting the value as of var to whatever x is passed. Now another way to do the same thing, and a simpler way to do the same thing, is basically to just give it in the brackets, right, and just saying var is equals to x, right? So that will also do the same thing, right? And let's just give this like this so that there's no confusions, right? So it could have been done this way also, and this is the same way as what we were doing in the initializer list syntax. This is the same thing that we're doing like this, right? So next in this, now as var is a private member of this class, we have to create its setter and getter also, so that we have some access to this var. So setter will allow us to change the value of the private member, and getter will allow us to get the value of the private member. So we can't directly access and change our private member, but we have created a setter method and a getter method for it, so we can use that to either change or either to get the value of this var. So now in set var, what we're doing, we are taking an integer s and we are saying var is equals to s, right? So we are saying var is equals to s, right? And what will happen, it will basically change the value of this variable to whatever we pass, right? And basically we're coming out of this method, right? And then we have a get var method that is returning an integer, right? And basically this will return the value of var, right? So basically this will give us the value of var whenever we call it. Now in the main method, we are creating an object of the a class, right? And to give the value to this constructor, we have to pass it over here when creating the object only. So we are just passing it 1, so 1 will be gone to the a constructor, and the a constructor will set the default value of var to 1. Then we say a dot set var 2, right? So we are passing 2 to set var, right? And basically it's saying var, it's changing the variable value of var to s. So s is 2, right? So we are passing 2 as s, and it's changing the value of var to 2, right? So now the value of var is 2, and then when we do a dot get var, that will bring to the value of var for us, so that is 2, and that will be printed using cout, right? So basic constructor passing like having default argument in the constructor. This was a basic example. Now there can be some modifications in this code. One way, instead of doing var equals to s, what we can do, we can say this var is equals to s. Now this is basically you can say it's an like it's giving you access to the object, right? So it's basically giving you access to the object on which this function is called. So basically this is giving you access to the object on which set var is called. So like a is calling set var, so this is giving you the access to basically a, right? So now what is happening over here, this, what it is returning, it is returning you the pointer. So basically what this is doing, it's returning you the pointer. So this is returning you the pointer right? It's giving you a pointer value, right? So it's giving you a pointer and you are changing its s, right? So from inside the class, so you're changing its var, right? So this is a pointer, like memory address, you can say. So like we have all the memory address 0x123 4, right? So this will give you the memory address of this object, right? And its var, from set var only we are doing all of this, and its var is being changed to s. So what we are doing, we are using this arrow syntax. We have seen previously also that when trying to change properties and methods, when trying to access or change properties or methods of your object, when you have its memory location. So whenever you have a memory location of an object and you want to change its property, or you want to access its property, or you want to change its method, or you want to access its method, then you have to use this arrow syntax. Now over here, this is giving you the memory location or the memory address of the object on which set var is called, right? So basically it is giving us the memory address of a, and we are using the arrow syntax to basically access its var and change it to the value that is passed over here as s, right? So this is another way of doing var is equals to s. So this is available for basically it's you can use it in every class over here, and on whichever object, basically on whichever object your method or some property like your method is called, so this will point to that object. So this is basically pointing to the a object, and basically this is a memory address, so we have to use the arrow syntax to basically change the variable of basically that object, right? So a's memory address, from a's memory address we are directly changing the value of the var variable, and we are changing it to s, right? Similarly, what we could have done, instead of returning var, we could have done return this var, right? So return this var, what this would do, this will basically get var, we are calling get var on a, so this is basically pointing to a, right? Now this is the memory address of a, right? So we have to use the arrow syntax, and from the memory address we are basically getting the value of var, and that is being returned, and that is printed over here, right? So this will work exactly the same way, right? So this is working exactly the same way. Now instead of doing this, there was this another approach. So let's just look at that. Let's just delete this and let's just look at this. Now over here what we are doing, we are trying to create an object of the a class only, but using the new keyword, right? So now by using the new keyword we are creating an object of the a class. Now what this will do, in the new keyword will create an object for the a class, right? We are passing it 1 and everything is happening, and the default value of var is set to 1 and everything is happening normally. But what difference we are getting from the new keyword, the memory address of the object, the new object that is created, its memory address is being returned, and that is being saved in this a variable, and that's a pointer also. You can see we have created a pointer that is basically telling that a has a memory address. So this a variable will have a memory or address of an object of the class a, right? So a is basically having the memory address of an object of this class capital A, right? And then as a is a memory address over here, we have to use the arrow syntax to access or modify any of its properties or methods. Now to access its set var method, we are using the arrow syntax, and we are basically saying set var, right? So we are calling set var on it, and we are passing it 2, right? So basically 2 is being passed to set var, and basically that is changing the value of var to 2. And then when we say get var, we have to use the same arrow syntax, and basically that is returning the value of the variable, and we will get 2. So in the end, var equals to 2 will be printed, the same that was happening before, right? So I hope this example is also clear over here.
Yeah, it's clear.
Alright, and one more thing, just when we don't pass anything, then this default argument that has this default value that we have given over here. So x is a default argument, so by default it will take x to be 0 when we are not passing it anything. So now x is 0 as we are not passing it anything, and the variable's value is changed to 0, right? And it was already 0 only, and basically we're just resetting it to 0, right? So this will also work the same as what is happening. It will set the value of var to 0, but then we are directly using set var to change its value to 2, right? And then then we are getting the var and we are getting basically 2, right? So this was the example. Over here there's an explanation also, that here we see a default constructor with no arguments and a default constructor with one default argument, right? So over here basically we didn't have any two examples, we only had one example, but no worries. We saw a default constructor with no arguments, so there was the constructor only with one default argument. So default constructor with argument has a default parameter x. So it has a default parameter x that we have given over here, right, which has been assigned a value of 0. So its default value is 0. So if nothing is passed to x, then x value will be taken as 0. Now here are some key points. Default arguments are different from constant arguments. So that these default arguments that we have, there's types of constant arguments also, right? As constant arguments can't be changed, whereas default arguments can be overwritten if required. So default arguments, what can happen, they can be overwritten, and mostly they are overwritten, right? So basically default arguments can be overwritten, right? So this is a default argument where we are overwriting the value of this default argument x over here, right? So when passing 1, this is overwriting the value of x that was previously 0, now we are changing it to 1, right? So basically in default arguments the value of your parameter can be changed, but there are some things called constant arguments also. So now in constant arguments, what happens, basically you cannot change the argument. So whatever you have defined to be the value of that argument, that will remain the same, and you won't be able to change the value of that argument. So if over here, for example, I say constant arg, right? So this is not how we create a constant argument, but if we say over here this is a constant argument that is equals to 1, so now we won't be able to pass the value to this constant arg. So if we try to pass this a value to this constant argument, that will lead us to an error, right? So default arguments are different from constant arguments, as constant arguments can't be changed, whereas default arguments can be overridden if required. Now default arguments are overridden when the calling function provides values for them. So the default arguments are overridden when the calling function provides values for them. So when we are providing a value for this default argument, that value is overridden. For example, calling the function sum 10, 15, 25, 30 overrides the value of z and w to 25 and 30 respectively, right? So when we were calling the function sum with 10, 15, 25, 30, so that is overriding the value of z and w as 25 and 30 respectively. Now when a function is called, the arguments are copied from the calling function to the called function in the order left to right. So when your function is called, the arguments that are there are copied from the calling function, so they are copied from this calling function, right? So or we can take this example, they are copied from the calling function, right, to the called function. So they are copied from the calling function from here to the called function that is over here, right? So they are copied to the called function and are assigned from right and are assigned in the order left to right, right? So in the order left to right. So basically from the calling function over here the value 10 is being copied to over here x, right, from left to right. So basically first 10 is copied and it is set as the value of x, then 15 is copied and it is set as the value of y, right? And over here 25 was copied and set as the value of z, and over here 30 was also copied, which was set as the value of w, right? So over here from left to right, the values are copied from the calling function to the called function, right? So therefore sum 10, 15, 25 will assign 10 and 15 and 25 to x, y and z respectively, right? Which means that only the default value of w is used. So now when this is copied and set to as the value of x, and this is copied and set as the value of y, and this is copied and set as the value of z, then the default value of w will only be used, right? Finally we have, once a default value is used for an argument in the function definition, all subsequent arguments to it must have a default value as well. So basically what is happening, if you are giving a default argument over here and you have some parameter after it, then every parameter after it should have a default value as well. So basically we are giving z the default value 0, so every parameter after it, like w over here, should and must have a default value. Now why is that, right? So why is that? So basically what will happen if you don't give a default value? For example, if it was allowed, right? So let's just interpret it is allowed that we can have normal arguments or parameters after default parameters. Then what would be happening when we don't want to we want to use a default value of z? Then what will be happening? We are passing the value of x to as something, we are passing the value of y to something. We are not passing the value of z because we want to use its default value. But now if the argument or parameter after z is not having a default value, so the argument or parameter after z is not having a default value, then what will happen? That argument won't receive a value, right? So when passing the value of x, when passing the value of y, and we want to use the default value of z only, then the argument after it, like w, which does not have a default value, right? So if let's just think that it was allowed not giving default values over here after a default argument, then also this will lead to us to an error at some point of time, as when we pass x, when we pass y, we don't want to pass z, then w will also not receive a value, and when w will not receive a value, it's a mandatory parameter, and when w won't receive a value, then it will lead to an error. So whenever you are giving a default argument, all the arguments after it must have a default argument, right? So once a default value is used for an argument in the function definition, all subsequent arguments to it must have a default value as well. It can also be stated that the default arguments are assigned from right to left. So for example, the following function definition is invalid as a subsequent argument of the default variable z is not default, right? So basically when not giving the value to w, basically this will lead us to an error, right? So now it can also be stated that the default arguments are assigned from right to left. So all the default arguments that you're giving must be assigned from the right to left. So the rightmost will be a default argument. Then its previous one can also be a default argument. Then its previous one can be a default argument. So basically from right to left you will see default arguments if you have any, right? So now we are on the advantages of default arguments. So default arguments are useful when we want to increase the capabilities of an existing function. So basically default arguments are useful when we want to increase the capabilities of an existing function, as we can do it just by adding another default argument to the function. Now this is a great example. Over here, let's take this example only. Let's just not overload it, right? So let's just not overload it, right? And over here only we have this sum function which has x, y, z and w, right? So now let's just say these are mandatory parameters. Let's say z and w are mandatory parameters, right? And basically we are passing it 4 values. Now if we want a sum function that basically has 5 values, right? So that basically has 5 values also, right? That basically adds 5 values. Then either we can overload this function or create a new function sum2, or instead of going the lengthy method, what we can do, we can just add a default argument over here, right? So that the previous functionality is not basically there's no change in the previous functionality also. Now for example, let's just add int v is equal to 0, and over here we can add plus v. Now look at this. When added we added v, it's a default argument, and we are doing plus v. Now is this function call being affected? We are passing it 10, we are passing it 15, we are passing it 25, and we are passing it 30, and basically when they are added we get 80. So the 80 that we were getting before, 80 we are getting now. So this function call that is already there is not at all affected, right? So this is a very big major upside of default arguments, that the function call that you have already done, function calls that you have already done are not affected by adding a default argument. But it's still, its functionality is increased. Now this function now has a capability to add 5 numbers also. So now this has the capability to add 5 numbers also. So now these all can also be added. Before, without the default argument, we could not add 5 numbers, we could only add 4 numbers. But with the default argument, this function now has the capability to add 5 numbers also. So this first one will give us 80, and the second one will give us 130. Right, great. So next advantage, it helps in reducing the size of a program. So that will reduce the size of your program also. Like instead of overloading the sum function, or instead of creating a sum2 or sum3 function, right, we are just adding a default argument. So the overall size of your program is also very small. It provides a simple and effective programming approach. So it's a simple, right? We just we just added a default argument and we just said plus v, right? So it's a simple, right? So it's a very simple and effective programming approach. From just adding a default argument from 4 parameters, we now also have the ability in the sum function to add 5 values. And default arguments improve the consistency of a program. So basically they also improve the consistency of your program. Now there is also a disadvantage of default argument, that it increases the execution time, as the compiler needs to replace the omitted arguments by the default values in the function call. Now when using default arguments, the process is not that simple. When passing nothing to v, what is actually happening, it's not just over here setting the value of v to 0. It's not over here just checking that if v, no value is passed to v, then set it to 0, right? It's not doing it like this. What it is doing, when no value is being passed to v, then it is taking the alright, so it's taking the value of v, right? So it's basically taking the value of default value of v, it is taking it and carrying it over here, it's putting it over here, right? And then this function call is made, right? So it has to do so much processes when using a default argument. It's basically what it's doing, it's taking the v value, basically it's taking the v value from here, basically from here, this default value v from here, it's taking it and putting it over here, and then the function call is made. So the execution time is very much, right? So basically it increases the execution time, right? And this was about default arguments, very fun chapter, and I hope everything is clear, so that we move on to the next chapter, inline functions in C++.
Yeah, it's clear.
Alright, great. So inline functions. So now inline functions are basically those basically very small functions. So you can use the inline keyword to basically before very small functions, right? And what will happen, instead of the normal way of execution of functions, basically the wherever you call the inline function, there whatever body of the inline function you give, that will be replaced over there. So if I have an inline function x, which is basically just performing one operation, right, and returning something, then whatever code I give in x, that will be replaced wherever I call it, right? So we are going to see that in detail. And inline functions are basically used when your execution time is less than the switching time. So what is the switching time? Whenever you call a normal function, right? So whenever you are calling a normal function, that will basically allocate some memory to it in the stack memory, right? So there's also memory, stack memory, where your memory will be allocated for your function, and from there you will get your arguments and everything will go over there first, right? So this switching will take place where stack memory first is allocated, and then the arguments that you give are taken to the stack memory, then the function is executed, right? And then there's some value returned from the stack memory, right? And then you're further using it, right? So basically all this whole process is the switching process, basically allocating some stack memory, taking argument to the stack memory. So this is all switching process, right? So now switching, when your function is very small, right? So it's just your function basically is performing one operation, right? And what you're doing such a lengthy process, right, for this or for everything, right? So you're creating a stack memory for such a small function, you're taking its arguments over there, right? So you are basically your switching time will then be more than the execution time. And basically when switching time is more than the execution time, then logically it just makes sense to basically just remove that switching time, right? So instead there should be no switching. So basically you can create inline functions for very small functions, and wherever you call the inline function, there whatever the code that you give inside the inline function, wherever you call it, it will be replaced by the code, right? So now let's just move on to the article. So C++ provides inline functions to reduce the function call overhead. So basically that switching part is an overhead, right? So basically before the execution, there's this overhead, that is the switching part, where this stack memory allocated, then the arguments are taken place, then there's execution taken place, then our values returned from there, right? And then basically the whole process is completed, right? So basically inline functions are there to reduce this function call overhead, right? An inline function is a function that is expanded in line when it is called, right? So basically it's expanded in line when it is called. So whenever you call it, all the code that you give in the inline function, that will be replaced wherever you call it, right? So when the inline function is called, whenever the inline function is called, the whole code of the inline function gets inserted or substituted at the point of the inline function call. So wherever I call, for example, I have an inline function x, and wherever I call it, then all the code inside x will come over here over the function call, right? So that function call will be replaced or substituted or be substituted by the code, right? The substitution is performed by C++ compiler at compile time. So when the code is getting compiled, then the substitution is performed. An inline function may increase efficiency if it is small. So inline functions are giving us an advantage when they are small. If you create a very big inline function, then it's a very big negative, and we are going to see how making an inline function that is very big is a negative point for us. So here's the syntax. We basically give a normal function with return type, function name, parameters and everything. What we add is the inline keyword before the function return type, right? And here there is the flow chart of a normal function and an inline function. Basically this is a comparison. So basically we are going to we have less than a minute left, so we are going to continue with inline functions in the next class, right? So
Okay.
thank you.
Thank you.